Welcome students to one more session of your chemical thermodynamics. So till now we have learned the different terminologies of thermodynamics. Then after that I've taught you the concept of work, that is in a reversible process, irreversible process, then adiabatic expansion, compression, everything I've taught you. Then I did a series of numericals, that is from your NCRT, as well as biochemistry, the most important numerical based textbook. Then from that, I also taught you what are the formulas you should remember while doing your thermodynamics. That thing also is covered. Now let us finish off, because we have completed all the numericals. Let's finish with the next topic, the theoretical concepts of this chapter. So what are they left? We are left with heat capacities. We are left with Haber cycle. We are left with Hess law of constant heat summation. Then we are also left with different concepts like entropy changes. We'll do all together slowly but very neatly. We'll do it. So today the topic which I'm going to teach you is Born-Haber cycle. So who has introduced this Born-Haber cycle? Basically, it was introduced by Max Born and Fritz Haber. So these were the two scientists who have discovered this. So their work is really very, very important. So what did they do? So they want us to learn, or the process which they've discovered makes us to learn, it will describe a method for calculation of lattice energies. So what did they give us? They've taught us, these two have taught us method for calculation of lattice energy. This is what they have taught us. So we are going to learn how to calculate lattice energy, how to calculate the summations, everything we will do it. So finally we will try to calculate lattice energy from different steps. So what actually is lattice energy? Let us define. Right? So now when I speak about an ion, a positive cation, a negative anion. So what is the force of attraction holding them? It is basically electrostatic force of attraction, isn't it? Right? So your concept starts from two ions combined together. So the first point which you should remember is both positive, and that is your cation, and negative ion. How are they held together? Are held together by electrostatic force of attraction. Electrostatic force of attraction. This is the first concept which you should remember. Now what actually is this lattice energy which they've explained? So let us write the definition. So they said lattice energy. Okay, let us write that if you have to define. So lattice energy or lattice enthalpy, both are same. How is this defined? It is defined as a change in enthalpy. Okay, let us write change in enthalpy. What is enthalpy? Enthalpy is nothing but the heat change. So let us write enthalpy as heat change. So when is this heat change occurring? When 1 mole of a solid crystalline substance is formed from its gaseous ions. Right? So then once again, this particular change in enthalpy, or the heat, whatever change it occurs in that particular system. When does this heat change occur? When 1 mole of a solid crystalline substance. Okay, when 1 mole of solid crystalline substance, from where is it formed? Is formed from its gaseous ions. Okay, so what actually is this? We will see it step by step. So I will now remember the definition like this. Now let's see. So let us draw one Born-Haber cycle, what Max Born and Fritz Haber has given to us. So I'm going to take NaCl crystal. Okay, now they have basically taken NaCl crystal and they've drawn the Born-Haber cycle. So in the exam, when they give you, first write the definition of or the concept why are we speaking about ions. So the force of attraction between them is electrostatic force. Then you're going to write the definition of lattice energy, because we are going to use that concept. That is where the Born-Haber cycle lies in. So after writing the definition, pick up this flow chart. So here we are going to draw the Born-Haber cycle for NaCl crystal. So this is called Born-Haber cycle. Right, cycle, CLE. Done. First, what are we going to do? We are going to take sodium solid. Okay, this combines with half chlorine. these two combined together forms NaCl solid. So now, first of all, this is your direct step which you're learning. But what happens if this occurs in steps? First of all, let's start. Let us take this as step 1. This is step 1. Now from here, let's pick up this as step 2. Now what happens in step 1 or this particular process? There is always a change of or the conversion of solid sodium into solid gas. Okay, so the sodium, the gaseous state of sodium. Once again, it's a conversion of sodium metal to gaseous atom. What is this process called? Conversion of solid directly to gas. It is nothing but sublimation, isn't it? Sublimation. Now this is over. Let's take this step 2. In step 2, what happens here? This dissociation. See, now this is your chlorine molecule, isn't it? Now this chlorine molecule, it dissociates into chlorine atom. Yeah, so this dissociates into chlorine atom. So now what is it doing? It is dissociating from chlorine molecule to chlorine atom. It is nothing but dissociation, isn't it? So enthalpy of dissociation. Simple. So how do you write this? This is, okay, let us write in words first. This is enthalpy of dissociation. Why? It is a conversion of molecule to atom. Because molecule breaking up into atom. That's over. After that, from this step 2, this is step 1, sorry, this is step 1, this is step 2. Let us come to step 3. So in step 3, what is going to happen? Here, the gaseous sodium, whatever is there, it is going to convert into sodium ion. So here, gaseous sodium is going to convert into gaseous sodium atom by losing one electron. So what is this process called? The process of converting the gaseous sodium atom into sodium ion is called enthalpy of ionization. Means you are removing one electron from this. When you are removing one electron, what is the process of removing an electron from the valence shell is nothing but ionization enthalpy, isn't it? So this is called ionization enthalpy or ionization energy. Done. Now let's come back to step 4. So now when I take this step 4, remember, here in this particular case, this one electron is gained by this chlorine atom. So what is this do? Chlorine picks up from here, this electron goes here, this is picked up by chlorine, this chlorine atom, and this becomes chlorine anion. Now this is sodium cation, gaseous ion, chlorine anion, gaseous ion. Both are gaseous ions. Now this, during this this amount of energy released, like no, what should I say, energy released, but what is this? The ability to release electron, means the process of releasing electron is ionization enthalpy. The process of accepting electrons is nothing but electron affinity. This is sublimation. This is energy enthalpy of dissociation. Okay, this is ionization enthalpy. This is electron affinity. Now what happens? Sorry, here in this case, these two, now this is one gaseous cation, this is one gaseous anion. These two combine together and they are going to form NaCl. This is step 5. What is this now? What is this step 5? Here sodium metal and your means the sodium cation as well as the anion, the positive and negative, they combine together. Right? So here when both combine together, the sodium and the chloride ions both get together and they form the crystal lattice. Together they form the crystal lattice, solid crystal lattice. During this process what happens? There's amount of energy released, isn't it? That energy released is called lattice energy. Remember that. That whatever is blue, that's called lattice energy. So what do we have? Sublimation for converting into solid to gas. Enthalpy of dissociation for converting into chlorine molecule to atom. Ionization enthalpy to remove an electron. Electron affinity to gain an electron. So now this one and this one both will combine together to form solid crystal. Now let's see step by step. After drawing this, you need to mention step by step in your paper. So here, what are the different steps? So how do you write? Enthalpy change for direct formation and enthalpy change for indirect formation. Both the things. First of all, when we take enthalpy change for direct formation. Directly, it will not go step by step. Direct formation, okay, there is no I. Direct formation, how do you write that? First, sodium as a solid, it's going to combine with half Cl2. This is chlorine molecule. So directly they will combine and form NaCl, solid crystal. Now during this, the enthalpy change, the direct formation, how much is the enthalpy change? The standard enthalpy change I observed is minus 411 kilojoules. This is when that combined directly. Suppose if they are combining indirectly, that is all the steps together. So let us write enthalpy change, okay, enthalpy change for indirect steps, in enthalpy change by indirect step or for indirect steps, by indirect steps. Let us write this by, I'm sorry for striking many times, right, by indirect steps. Now what are the steps we have? How many? We have 5 steps. What are they? Step 1, let us divide this as step 1. This is for this, let us write step 1. The second one is step 2. Let us take the next one as step 3. Let us take this as step 4, and we also have step 5. Now in step 1, what is happening? Right? So in step 1, sodium solid is getting converted into sodium gas. Now what is this called? This is nothing but conversion of sodium solid to gas. This process is called sublimation process. Sublimation. Let us take this enthalpy change as delta H1 and the energy is absorbed. So it is 108 kilojoules. Endothermic reaction, because it requires energy to convert from solid to gaseous. Now in the second step, what is the second step? Half chlorine molecule, here it's getting dissociated into chlorine atom, gaseous atom. So the dissociation of chlorine molecule into chlorine atom, what is this called? Enthalpy of dissociation. So enthalpy very well known, okay, we will write it as enthalpy of dissociation. I'm writing the process. So let us denote this as delta H2, which is equal to 121 kilojoules. So it is dissociate, molecule is dissociating into atom. Now in step 3, here it is a conversion of, in step 3 what? This, now this sodium gaseous atom, whatever is there, this gaseous is going to convert into gaseous ions. During this process, what happens? One electron comes out. The process of removing, or the enthalpy of ion, this process of removing an electron or losing electron is called ion. Means what energy do I require? I require ionization enthalpy. So the enthalpy of ionization here, this one is ionization enthalpy. Let us denote as H3 naught, which is 495 kilojoules. So the enthalpy of ionization is ionization enthalpy per mole. 495 kilojoules per mole of energy is absorbed when you're converting so gaseous sodium atom into gaseous sodium ion. Now in step 4, what are we going to do? This chlorine will accept this electron. What do I get? I get gaseous anion. Now during this process, what happens? The energy is released, isn't it? This is energy absorbed, this is energy released, because it is gaining electron. Whenever something gains electron, energy is released. And this process means this is electron affinity, isn't it? The energy released. So here we are going to use electron affinity. Here we are using sublimation, here using enthalpy of dissociation, here we are using ionization enthalpy, here we are using electron affinity. Now let us take this as delta H4 naught, because affinity it is absorbed, it is released energy. That value is equal to minus 348 kilojoules. Done. Now let us see step 5. What is step 5? In step 5, we have a combination. Now here sodium, whatever gaseous ion has formed, it's going to combine with chloride ion. And they form the solid crystal lattice of sodium chloride. So sodium ion, gaseous ion, as well as chloride gaseous anion, both together they form the crystal, sodium chloride crystal lattice. Now during this process, what happens? The energy released in this process. is the negative of lattice energy. Means here the energy is released. Isn't it? We said, isn't it? Lattice energy is a change in enthalpy when 1 mole of the solid crystalline substance is formed from its gaseous ions. That's why here we are going to take delta H, which is the fifth step, phi naught is equal to minus lattice energy. Still we need to find this. Right? Now. So what did Max Born and Fritz Haber give us? They have given us a method to calculate lattice energy. How can we do? Basically in the step 1 direct step, how much did we get? We got minus 411 kilojoules, isn't it? So he said, now according to Hess law of constant heat summation, we are going to add all the energies together, isn't it? So what did he do? Delta H01 plus delta H2 0 plus delta H3 0 plus delta H04 plus delta H05 is equal to minus 411 kilojoules according to constant heat summation. Now here what is the first one? What do we write? We have written the first one as sublimation, isn't it? So it is the amount of energy absorbed, that is 108 kilojoules. The second one we said it is enthalpy of dissociation. There also energy absorbed 121 kilojoules. Here H3 is again ionization enthalpy absorbed, so energy is 495 again plus. In the fourth case it is electron affinity. Here in this case energy is released, electron affinity energy is released, that is nothing but 348 kilojoules. And minus the fifth one, it is nothing but lattice enthalpy, that is lattice energy. Now take this lattice energy outside, because this is what we are finding. When you solve this lattice energy part, you get an answer of plus 787 kilojoule per mole. This is what is the answer. So here totally when I take this whole thing, which we have got equal to minus 411 kilojoules. So when I substitute this value, so I get almost 411 kilojoules. So this is your Born-Haber cycle, students. So remember, lattice energy for this example, that the whole thing, the concept of finding lattice energy was given by Born-Haber cycle. So this is your concept of Born-Haber cycle. Simple. Try to do step by step in your exam, starting from the concept of electrostatic forces, then write the concept of lattice energy, then do it step by step. Thank you for watching, students.